Okay, I'm sharing my Solaris machine with you, the screen there. So I'm going to show you some of the commands with Proc file system on Solaris. There are some additional commands that are on Solaris that is not on Linux or other operating system. And I want to cover those ones so you understand how beautiful they handle some of these things with the Proc file system. As you can see, /proc, like Linux and other operating system, is a pseudo file system, and it has process ID of the each running process. So, for example, if I look at the Solaris machine, this is a uname -a. It's a Solaris 11.4, the /etc release version. It shows you that, and in order to see the system information, I'm going to find out my running bash. So if I just do ID here, root, and I say get and password root, and that's my process actually the record in the etc password file. I could do a grep -I for root on etc password file. It will just give me the same information. So the first one is my user ID, and then my username, and then X is for there's an entry on the shadow file for the password. 0 is the root user ID. Another second one is group ID for the root. The real name is super user, and then the home directory /root, which is right here as soon as I go, and then the bash is user bin bash. So if I type a bash, I could see that that is there. Bash is a built-in type -a bash. It will tell you the same thing, that is user bin bash is the default there. And then what type of file it is user bin bash is executable file. This ELF means executable link formatted, 64-bit LSB executable AMD 64. And at this time, clear the screen, do another PS. Notice that this PS 1571. So if I do ls -ld proc for 1571, that is my bash. I could do the same thing with ls -l on this / files to see what are the other files, like file descriptor, stat, and other things. Notice that this one is still having the status, so you could get the information like we were getting it before. You could go say cat /status, and then that is actually binary in here, and the other one had the executable. So right here, if I just do stat on /user bin bash, it will give me statistic about that binary. And then now, knowing the information, I need to know some more detail on it. LDD, like I told you on the other one, is on this one also shows the loader dynamic link libraries. And then this case is showing that. But if I do a pmap on the process ID of it, which was the process ID was here is 1571, then you can see that in addition to these two, there's a third one, the Unicode method, that also get dynamically linked. So if I just say pstat or pstack to get the pstack of process of that one, I get the memory location and all the program calls that are there. And you see this main is coming here because it's written in C. It has a lot of these function calls that are passed on. If I do a pmap of it, which stands for process map, this is again a Solaris only, and some of these commands are not on Linux. So pmap, process map, you will see that all the binary shared object, everything that are getting loaded for bash, user bin bash, it is store the memory location, how many record, and what are the permission, whether the part of it is text or the actual data. And then some of it is coming from the heap. And so it is on the memory that contents is on the proc file system, it is doing that. And if I just do PS again, notice that this process is 1571. So if I say P3, a process 3 of 1571, all the sub-processes that are tied with it, that invoking a child process, you can see the main process started with 1521, and then the parent of it is 1520. So if I look at PS minus, remember PS command, I said I'm going to cover PS also. I say PS EFA, means show me the extended information, F full, and then A for all. And that information, I want to see 1521 grep minus, minus I, because 1521 is a number, so you don't have to match a string. And then notice that 1520 is the parent process of it. So if I do a P3 of 1520, 1520 most likely is invoked by another one. Eventually, they will be having a parent of 1, which is init. So 1520, and then it is a GNOME terminal server, which means this terminal, if I exit out of this one, most likely my GNOME terminal is this session 1520 that I got that process. So if I do a P3 on 1, which is the mother of all processes, this list is big. And 1520 is one of the child process in there too. You can see. So P3 is really nice command. And then on Linux, I believe they have that command as PS3 if they provide it, but not for everything. Equivalent to trace command, they have strace. And they have added some of proc file system, but not all of them. Like pwdx is there. And then pwdx, print working directory of executable. This one is slash. And then if I just go pwdx of 1521, which is the bash, it says export home w.p. I invoked it. And then for 1520, pwdx of that one is also same thing. And how I know that one, and the proc file system, on the proc file system for 1520, there's a exact there. You can list that one, or current working directory. Let's see, there's file descriptor, LTD privilege, status. This is the current working directory, the one that is showing there. So PWD of that one was, so PWD of this one, 1521, is that. And if I just say ls minus ld proc 1521, 1521, current working directory would also say the same thing. And then cut that one, the current working directory is equivalent to, is a directory. It's file slash proc proc slash 1521 slash current work. This is a directory actually. Inside here, you have more files. ls minus ld, L actually, and that's a symbolic link to something else. Let's see, just curious proc 1521, and then current working directory with a symbolic link. It doesn't show this because it's symbolic link to the content of memory. That's when you see the pwdx there. So if I say which p3, there's a lot of the pwait, pstop, pstack. So if I do ls minus ld, use a ben p something, that you notice that in addition to other ones, Python is there. Let me just do ls minus d pipe more. So slash page, page cat, pargs. Parg is one of the proc processes. Will give you arguments. Page, pmemory, pstack, ptop. Let's see how many more of them are showing here. Pcommand page, pargs, pwdx. P-credential config and P2. And then there's going to be on the profile stuff also. And then P-stop, wait, another one should be there. Page, P-files, PFC shell. This is the profile C shells that is also available there. PFSH for profile for SSH born shell and PF bash files. Pip, which is for Python. Pip of it. Packages, package add, package remove, package def. And notice with package command, you have package command, you have pkg add, pkg condition, move, rem, ls, info. Well, we could check a lot of these ones here. And then with pkill, for example, pkill process kill. And then with package send, you want to configure it. PLDD is the one that we just used. PL grep command, plimit, you get the limit. Pmap for pros map, we just used it. There's a lot of it. So imagine how powerful it is to give you all the things that you need. There's one command that I really like is preap. It should come up here somewhere. Preap, prstat. Prstat and pstat, all of those ones are give you a system statistic report. Right here, preap. Preap is very useful command. When you have on Unix machines zombie process that they were original defunct process and they turn out to be zombie process, you can still claim them by doing a preap on the process ID of the zombie process, and it will look into the assembled tables. It will clear all the orphan childs and then the parent that had died, and then it will just clear it from the assembled table. Because when a parent dies, the process ID becomes defunct as a result of the orphan child not having the resource, either CPU or memory or IO bound. And as a result, init, as the mother of all processes, adopt that orphan process, the child process that is runaway process. And then you can either use the kill command to kill it, and sometimes when you kill it, because they are becoming zombie, they're just kind of like in a zombie state. You kill the parent, the process ID, it just, because the parent has died, it just spawn another process ID for the same name. So you cannot continuously kill it. And then on Linux machine, unfortunately, if the admin cannot identify the process ID that is supposed to be killed, then they reboot the machine. That's not a solution. You should look for the parent process ID of it and identify that runaway process and get rid of it that way. And then after that, init is going to clear it from the assembled table because there's no zombie process anymore. But with Solaris, they have this command user ben preap it actually does all the work for you. As long as you just pass in the process ID of the zombie process, it will clear it for you. You don't have to find out the parent process or the runaway process associated with it. That's why I like, in that case, Solaris. It has more functionality. So prstat and pstat and all the other ones are there. And you can see like pstop, pstack to get the stack, pwait, prun, all of that. Process signal, you can check on that one. There's a lot of these commands. pwdx, as we covered. Pwait to wait for the process before it, p3, we did it ptime. There's so many of them. And it's all intuitive, based on the proc file system, based on the process. And we're on the Python.